Welcome to Algo Thinker, where we decode the invisible algorithms running our lives. Let's get into it. Every time you open X, something strange happens. Tweets from people you've never followed, never searched for, never even heard of, appear in your feed. And somehow they're exactly what you want to see. How does a machine sort through 500 million tweets posted every single day and pick the 25 that will keep you scrolling? The answer involves a neural network with 48 million parameters, invisible signals you don't even know you're sending, and 145,000 secret communities you already belong to. It starts with scale. Every day, over 500 million tweets pour into X's servers. That's roughly 6,000 tweets every single second. Your feed needs about 1,500 candidates to work with, but there are 500 million to choose from. So the algorithm's first job is filtering. It splits the pool in half. 50% comes from people you follow, your in-network. The other 50%? Complete strangers. Your in-network is straightforward. The algorithm looks at who you follow, who you interact with most, and pulls their recent tweets. But the out-of-network half, that's the hard part. How do you find relevant tweets from people you've never even encountered? We'll come back to that. It's the most fascinating part of this entire system. Every single one of those 1,500 candidates goes through a neural network, not a simple filter, a real, production-scale deep learning model with 48 million trainable parameters. For each tweet, it predicts the probability of 5 different actions: that you'll like it, reply to it, retweet it, watch any embedded video, or click to expand it. But here's where it gets interesting. Not all actions are weighted equally. A like counts as 1x. A reply? 27x. 27 times more valuable than a like. The algorithm treats conversation as far more meaningful than a quick heart tap. And if the tweet's author replies back to you, that single interaction is weighted at 150x, 150 times the value of a like. The algorithm isn't just scoring tweets, it's optimizing for conversations that go both ways. All 5 predictions are combined into a single relevant score. Each tweet gets ranked. The highest scores rise to the top. But the model needs data to make those predictions. And the algorithm sees things you don't even know you're doing. When you pause on a tweet for more than 2 seconds, the algorithm registers that as a read. Your scroll speed, your linger time, whether you tap to expand a thread or just kept moving, it's all being tracked. These signals fall into 4 categories. Social signals: who you follow, who you reply to, who follows you back. Content signals: the topics, media types, and language patterns you engage with. Temporal signals: how fresh the tweet is and how your behavior changes throughout the day. And personal signals: your device, your location, your session history. Negative signals matter just as much. Every tweet you mute, every account you block, every tweet you scroll past without pausing, the algorithm is learning from that too. And all of these signals decay over time. What you liked last month matters less than what you liked this morning. Now, remember the hard question: how does X find relevant tweets from people you've never followed? This is the most elegant part of the entire system. It's called SimClusters. X has mapped its entire user base into 145,000 invisible communities. These aren't communities you joined. You didn't sign up for them. They were discovered automatically by analyzing billions of follow and engagement patterns. You belong to several of these communities simultaneously. Maybe you're in the machine learning cluster, the startup cluster, the electronic music cluster, and the space exploration cluster. Every user gets a vector, a list of numbers representing their membership strength in each of these 145,000 communities. And here's the key: every tweet gets a vector too. When someone posts a tweet, the system looks at who engages with it in the first few minutes and computes which communities it belongs to. Then it's just math. The algorithm computes the Cosine similarity between your vector and the tweet's vector. If the angle is small, the tweet lands in your feed. This is how a tweet from a complete stranger, someone with 0 followers in common with you, can appear in your For You tab. Because in the 145,000 dimensional space of SimClusters, You and that stranger are neighbors. The scored and ranked tweets then pass through a final mixing layer. Safety filters remove anything flagged for policy violations. An author diversity rule prevents your feed from being dominated by a single account. Content type mixing ensures you get a variety: text, images, video, links, not just the same format over and over. And a ratio controller maintains the 50-50 balance between in-network and out-of-network content. All of this happens in under 1.5 seconds. So the next time you open X and see a tweet from someone you've never heard of, and it's exactly what you wanted to read, now you know what happened. A neural network with 48 million parameters scored it. Invisible signals from your own behavior shaped the prediction. And SimClusters, a 145,000 dimensional map of human interests, bridged the gap between you and a total stranger. The algorithm isn't just recommending tweets, it's building a portrait of who you are, updated with every scroll, every pause, every tap, and reflecting it back at you. Right now, YouTube's algorithm is watching you watch this video. It's measuring your watch time, whether you paused, whether you'll click the next video. This video took over a week of research, code analysis, and custom animation to build. If it helped you understand something you couldn't before, hit like, share, and subscribe to let the algorithm know you want more. Next time on Algo Thinker. How does a Tesla drive itself using nothing but cameras? The answer involves 48 neural networks working together, 8 cameras building a 4D world in real time, and a system that replaced 300,000 lines of code with pure AI trained on billions of miles of human driving. It's the algorithm that learned to see. See you in the next algorithm.